All right, so stoichiometry is a study of the numerical relationships between chemical amounts in a balanced chemical equation. So the coefficients in a balanced chemical equation, they give us a ratio of particles, and that's what we've been using. So 2 molecules of propane react with 25 molecules of oxygen to produce 16 molecules of carbon dioxide and 18 molecules of water. But molecules is not the scale that chemists work on. 18 molecules of water is not enough to do anything with. So those coefficients from the balanced reaction give us a ratio of particles, but they also give us a ratio of moles. So we could rewrite this as 2 moles propane plus 25 moles of oxygen yields 16 moles of carbon dioxide and 18 moles of water. And then we can use that mole ratio to determine amounts of reactants and products. So for every 2 moles of propane that I use, I'm going to produce 16 moles of carbon dioxide. And that 2 is coming from the balanced equation, and the 16 is coming from the balanced equation. You could have the inverse of that. If I make 16 mole of carbon dioxide, it requires 2 moles of octane. Things don't have to be on the same side of the reaction in order for you to look at the mole ratio. So we could also say if I make 16 moles of carbon dioxide, I'm also going to make 18 moles of water. So these mole ratios are the key to stoichiometry. And again, they just come from the balanced chemical reaction. So before we get into chemistry examples, we're going to do pizza examples. So the reaction or the equation for a pizza is 1 crust plus 5 ounces of tomato sauce plus 2 cups of cheese yield 1 pizza. And the number of pizzas that you can make is going to depend on the amount of ingredients that you use. So I want to know how many pizzas can be made from 10 cups of cheese. So if I look at my reaction up here, for every 2 cups of cheese, I make 1 pizza. And so in your head, you're probably like, well, you can make 5 pizzas. But what you just did was stoichiometry. 10 cups of cheese. I need to cancel that unit. So I cancel cups of cheese on the bottom. It's asking for pizza, so I'll put pizza on the top. For every 2 cups of cheese, I make 1 pizza. So I can make 5 pizzas from 10 cups of cheese. Same thing with the sauce. I'm starting with 35 ounces of sauce. I'm going to cancel that unit on the bottom. For every 5 ounces of sauce, I can make 1 pizza. So with 35 ounces of sauce, I can make 7 pizzas. So that is what we're doing here. That's all we're doing. So don't get confused when we change from sauce and pizzas to propane and carbon dioxide. Okay. So how many I gotta add to this, how many moles of carbon dioxide can be made from 6 moles of butane? So write down what you're given. Cancel that unit. I forgot the mole. Come on, Miss O'Connell. So mole butane on the bottom. It's asking for mole carbon dioxide, so I'll put that on the top. And then I'll go to my balanced chemical reaction to get the ratio. So for every 2 moles of butane, I can make 16 moles of carbon dioxide. So when we do this math, we'll get 48 moles of carbon dioxide. Sig figs, we're back to math, so sig figs are back in play. The amount of sig figs comes from what you're given in the problem. So I was given 6 moles of butane, which is one significant figure. So I have to round my answer to one significant figure. Oops. So it actually rounds to 50. Okay. Looking at this example here, you always have to start with a balanced equation. Your mole ratio comes from your balanced chemical reaction. So always start by making sure you have a balanced chemical reaction. Then write down what you're given, 3.7 mole aluminum oxide. Cancel that unit. It's asking me for mole aluminum, so I'll put that on the top. And then I will use my balanced reaction, the coefficients for my balanced reaction, to find my mole ratio. 4 moles aluminum to 2 moles aluminum oxide. So this is going to be 7.4 moles of aluminum. It takes 7.4 moles of aluminum to make 3.7 moles aluminum oxide. This was 2 sig figs that I was given, so I round my answer to 2 sig figs. And that is it.